Okay, so everyone, welcome to the first of Bob's developer series. So this was Ian's idea, so thank you, Ian. Ian's the new organizer for Bob. If you guys don't know him, say hi.
Hello.
So we're aiming to provide a lot of educational material this year. So we're going to do some, Bitcoin blockchain 101 sessions, and we're doing this developer series. So let us know if you have any ideas of topics you'd like us to cover. We're going to do this. We're probably going to do some lightning node stuff soon, and we're hoping to line some other things up as well. So let us know what you'd like to see. So what we're going to be doing today is building a T-shirt store and accepting Bitcoin payments on that T-shirt store. So the idea is just to step through all of the things that are required to do that, just to give you a general overview of what you need to make that happen. The repo is public. It's up on GitLab, so you can fork it and do whatever you like with it. It is so not production ready. Don't use it for an actual T-shirt store. It'd be a very bad idea. So I'll let Ian have the floor, and it should be fun.
All right, so the style of this is, I made a thing, here's the thing, and we'll go from there. Okay, so in order for you guys to get started, just quickly, what is this? This is mostly organized as a node project, so it's JavaScript, but I usually write TypeScript. It shouldn't be a problem if you haven't done anything with TypeScript. The build process is a little bit weird, but you should be able to read the code just fine. If you want to follow along and build stuff, what I recommend actually is as soon as you run into a problem, find somebody else who hasn't run into a problem and start kind of working with them on the build. So I think this is not really tested on lots of environments, and I don't want anybody to just have to stop because some weird message pops up and they don't have time to debug it as we're going. So we'll pause and let people kind of reconfigure if they want to join some team that still has a living member as far as following along goes. Okay, so the main things that you'll need, you need Node installed, you need SQLite 3 installed. TypeScript, if you don't have this on the path, that's okay. We can deal with that. You'll need, if you want to actually run the node, you'll need to have Bitcoin D or Bitcoin PT. I put version 16, but that's not strictly speaking necessary. And to use that, you'll also need some header files for this message queue. And you can get those on Ubuntu by installing this. Okay, so this is all available. This is actually in the README for the folder for this particular instance of the dev series. And now I want to start out by wait, let me see. There's something I want to do. Oh, yeah, okay, right. So I'm going to be running a node here, and you guys probably won't have one running. If you have the capacity to run one, that would be cool, but I don't expect you to have that capacity. All right, here we go. This is my testnet Bitcoin node with some of my test transactions that I did. We'll use this to pay for stuff on the store. And in order to connect to that, you'll use my IP address, and you should put this somewhere. It's 10.11.4.209. Okay, so you'll have to change some of the configuration, and I'll show you where if you're following along and building, and you want to point your program to my node instead of spinning up your own testnet node. Okay, and we'll get into, if you're not really familiar with what that is, we'll get into what I'm talking about when I say node in a little bit. It's not this node. How many people here basically understand what Bitcoin is? Have maybe done a Bitcoin transaction? And okay, cool. So you understand it's a peer-to-peer network where all the software on the system basically maintains a data set according to some protocol. And in order to interact with this network, you have to run this program, and then your programs interact with that one. Okay, cool. So I won't spend any time on that. All right, so we're actually not going to start here. So let's actually start with the just T-shirt store without Bitcoin. So there's a, oh, I have to, hang on, let me push the branch that just has the T-shirt store in it. Alright, so this is my very crude T-shirt store. It's called before-01, so it's a bit smaller. And I just wanted to quickly go through this, just what it looks like, because we're going to be modifying this. So to start with, so what is this? It consists of a simple server application together with a single page client app that serves the store. And if you're following along, we can go ahead and build it. First thing we do, clone the repo.
Before 01.
Oh, it is? Okay, so here we go. And now the steps that we need to do in order to install this are run npm install. This gets all of our JavaScript dependencies.
Is that branch put? Oh wait, you just created a branch.
It should be on the GitHub repo.
I didn't get it when I closed.
You may need to fetch. If you cloned before I was quiet for about a minute, then that was me pushing the branch. I forgot to do that. Okay, cool. So now we've got our dependencies. All right. So for those of you, so is anybody having trouble with this part? We're just putting the dependencies somewhere where the various program parts can find them. So the next thing that we have to do is we have to build the database that runs the T-shirt store. So all right, so if you've got SQLite 3 installed, you can do it this way.
Can you keep the old commands on the screen as you move forward?
Yeah.
Oh no, I'm good now, but
okay.
Appreciate it.
Sure. Okay, so let's look at. We might as well see what our store looks like. So there's a catalog, right? It's got some T-shirts in there. There's a table for orders, and we're just keeping it very simple. And a table of purchases where we say exactly what an order consists of. And we've got 2 T-shirts, and we'll see those in a sec. Okay, so the next thing after this is we need to build the various pieces. So let's take a look. So the way that I've organized this is, this is a node package. So there's a file called package.js, and this contains some useful metadata, and it also tells you what scripts I've prepared for it. So we can do a build, we can do a server. There actually aren't any tests. That's a good thing for anybody who wants to play around with it and write some code and include it here, can make some tests. So let's go ahead and run the build. Okay.
What's your branch name?
Oh, for this is before -01.
Thank you.
All right, so now where is this stuff? Well, we can find this stuff in the build folder. Oh. So I like to use tree to put nice pictures of directories on the screen. Okay, so we just made a folder which has an app, and here, this looks like a website. It is. And we also should run the TypeScript compiler. Oh. Alright, yeah, so if you don't have TypeScript installed globally, you can get TSC by doing that thing. So just setting up a shell alias. And now, once we run this, we get an additional folder of build products called dist. In here, this is where our server is, in addition to some extra stuff. And now we can run oh, I made a script for this. Oh, we have to say what the database is. So we'll get into so I realize I'm not explaining anything. I'm just kind of walking through how to use this. And I'll actually go into it and show you how it's made in a sec. I'm just trying to get it all working. All right, so now we should be able to do this. Okay, so now if you open that app folder in your browser, if you open index.html, you should see the store if you've managed to get this far and build.
Can you please show the database command again?
Oh, sure. So this is to set up the database?
Yeah.
The very
Yeah.
first thing.
Yeah, so you can do it in lots of ways. I usually do it like this. So we're just going to feed the init script into SQLite 3, and I'm calling my database. Oh, actually I have to remove the database before you can do this. so yeah, we can pipe this script to the SQLite3 command. Right. Okay, now I need to, sorry, I need to does anybody have any questions at this point?
You said you're gonna walk through it again, right?
Yeah, absolutely.
Just
yeah.
just the commands that you did. I just want to make sure I got them all.
All right. This is a learning experience because I'm running I'm running this this terminal is a very, the one that I'm showing you up there is a in virtual machine, and so I haven't configured it to give me the code. I haven't made my own artifacts available. Bear with me. Okay, cool. I think we're basically there. All right. So now let's see. You should just open the file. I have to actually give it the path. Let me just run this server here.
DigitalOcean's cloud computing platform was designed with simplicity in mind.
No idea how that's
It's good. It's good to know though. I like when there's simplicity. Okay, so here's the T-shirt store. Okay, pretty sweet T-shirt store, huh? You can.
Amazon's in trouble, man.
Yeah, no doubt. So you can add to the cart.
I can download this website, right?
Yeah.
Yeah.
You're building it yourself. All right, let's see. All right, so it just does this stuff. Okay, so just to review, we started out, we cloned the repo, we went back in time to the before branch, we installed the dependencies, we built the database, we built the T-shirt store using npm run build, and we built the server by running TypeScript compiler, and then we started the server using npm run server. So here I'm going to just quickly put these on. Okay, so here are the steps. All right, we're not going to discover typos this way. Okay, so now let's actually just do a quick overview of what of how that T-shirt store is made, just so you have a baseline for when we start to patch it. Is everyone done with this? Well. Okay, so for the client, we just have a single page app. We're using, I tried to make it as small as possible, and so I am using a virtual DOM library in order to render everything, but that's it. So set up some sort of initial state for the application, and I'm using WebSocket connection to the server here. So we're looking for various messages. The server is going to push some products to us. Then we're going to display those products. The user is going to mess around with the page. Then we're going to collect an order from the user at some point, send it to the server. The server is going to respond with a confirmation that they received the order. And it's optimistic. We're just assuming everything is just perfect. Yeah.
Oh, can you share the command again?
Oh, yeah. Oh man. Yeah. I don't know how to make that abbreviate. Okay, so here's this. And so what you need to know about the server is also very straightforward. I don't really think we need to go into it before we look at the modifications. So what the server does is it just listens on a WebSocket. So first of all, it opens up the product catalog. Then it listens on a WebSocket. When the user connects, it sends those messages. It sends the products to the user. Then when the user sends it an order, it just doesn't. I mean, it just responds right away. Confirm, produces some random order ID and confirms. So it's not actually doing anything. All right. Now. So like tradition. So here. Okay, so if this were an actual T-shirt store, you'd have to, like, I didn't build in any sort of payment processing for credit cards, and but you should do that. And one of the options, if you want to add Bitcoin payments to your store, is actually to use a payment processor. And I think, Hannah, you wanted to come talk to us a little bit about using a payment processor for Bitcoin payments.
Yep. So I'm an e-commerce web developer, and I work a lot with open source e-commerce platforms. So LampStack's kind of stuff like WordPress's WooCommerce, Magento, DrupalCommerce, that sort of thing. And if you're working with an existing e-commerce site of that type, they're already going to have systems in place for processing orders and for managing payment gateways, credit cards, and all that sort of stuff. So if you're working with an existing e-commerce website, then you might just want to use something like a payment processor or find a plugin that already works with that platform that you're using. Is everyone familiar with payment processors? Yeah, so it's like BitPay, Coinbase Commerce, those sorts of things. BitPay has a whole bunch of plugins, so I work with DrupalCommerce a lot, and BitPay has loads of plugins for DrupalCommerce, or they have, for Drupal 7 and Drupal 8. And you can just install that, and in some cases, accepting Bitcoin payments on a website. If you want to use a payment processor, which you have to keep in mind does mean trusting a third party to do that. If you want to use that payment processor, in some cases, that is as simple as, setting up a BitPay account, installing a plugin on your website, and entering some API keys, and you're good to go. And how those all work can vary a lot, right? In some cases, they just give you a QR code, and someone can scan that QR code, and then they listen for that transaction, and then update the process on the website. Sometimes you actually get redirected to, BitPay's website or something of that sort. So they can work differently, and you can also find plugins out there that don't involve a third party. I haven't used any of those in a while, so I don't know how up to date those are, but I know they have existed where you can just install a plugin to just accept Bitcoin payments, to your local wallet. So there are lots of options out there, and just want to make sure you guys are aware that if you're working with an existing e-commerce website, you're probably going to want to use or at least look at some of those plugins. But let Ian get back to it because it's really cool to see the nuts and bolts of what we're doing here is, you know, what all of these payment processors and plugins are doing as well. Question?
Yeah. The bigger goal has always been to avoid the pay or the Venmos or the Braintrees of the world.
Yes.
Has anyone looked at a solution like tying it into Shapeshift and using that as a gateway?
You mean sort of like there's a project I know called BTC Pay Server that is an open source
Yeah,
project.
I'm looking at that too.
Yeah, and it's not like a third party. Well, I think they do have a service where they can you can connect to their server, that sort of thing. I don't think you're
Isn't the
trusting.
goal like to push to someone and then transact?
Yeah.
So can you use like Shapeshift?
Yeah, and payment processes in a lot of cases are just like that, you know, a bridge between an old system and a new system, yeah? And a lot of payment processes will also let you accept crypto payments, and then they'll process that straight into your local fiat and put it in your bank account. So they are often a bridge between those two worlds. But something like BTC Pay Server is something I've been looking into as well, which is just an open source project and isn't really a third party. Yeah. Any other questions?
Do you run BTC Pay Server? That's something that
Who does?
if one is interested in this, it's open source, you build it and run it on your own server.
I'm not entirely sure.
Okay.
I haven't really had a chance to dig into it yet.
Yeah, you can run it yourself. You can also do a one-click deploy to Azure.
Okay.
Directly from the GitHub repository for BTC Pay, and it will load a Bitcoin node and all of the software needed to connect to it.
Awesome.
So no third-party trust required, as long as you look at the software and understand what it does.
Yeah, it sounds good.
The new Coinbase commerce integration is also not a third-party trust necessarily, because it deposits directly to a BIP39 seed. So they don't take custody of the funds.
Oh, okay.
Cool. All right. Cool.
All right. So now let's go ahead and move forward in time to the integrated version. So here I want to just start out by I've written some thoughts about what you might. So when I was thinking about this, what did I have to confront in order to build this? And I'm taking the approach of being starting from complete ignorance, and just trying to think through what are the first thoughts here, just to touch on some of the concepts. And so ultimately, I think it's worth just walking through. If you're going to add Bitcoin payments to your website, what are some of the implications of that? So there's a few things that with a payment provider are just sort of handled automatically. But now, if you want to provide your user with Bitcoin payments, there's some obvious things that you have to take care of. So for one thing, you might want to decide if you're going to maybe quote the user prices in Bitcoin or not. If you're going to quote them prices in dollars, then you need to figure out a way to convert the dollar price into a Bitcoin price. So it's not hard, but that's one thing that you have to do. You also have to be able to know, if somebody sends a Bitcoin payment, how are you gonna know about it, right? Are you gonna go to some API endpoint? Are you gonna check a third-party service and ask for, periodically check what's the balance at some address? Are you going to run your own node? And if so, are you going to run a fully validating node, or are you going to try to get away with an SPV node? How are you going to get those addresses in the first place? Are you going to just generate one address on your phone and then copy paste that and put it on the website and have everyone send ones to the same address, or are you going to try to generate them in some way? When the user does pay with Bitcoin, and even let's say that, what are they doing? They are generating some transaction and signing it and broadcasting it to a network, and then it sits around for a while before being included possibly in a block, and then it may be included at some depth in the blockchain. And when do you give the user feedback after they clicked on the submit button? Do you wait to see that transaction? Do you wait for one confirmation? What happens if you give them feedback and then it turns out that for whatever reason, maybe the user is very unpopular and there's some sort of attack and all the miners agree to censor their transaction? What feedback would you give the user? So it's sort of interesting just to make the decisions around what the communication is going to look like. So I took the most sort of straightforward approach here and said that we're going to generate addresses, so one per order. So they're easy to look for, easy to know when a user has submitted such a transaction. We're going to give the user as instant feedback as we can. So we're going to tell them everything's okay as soon as we see that transaction on the network. And then that means that we then have to keep watching and ultimately figure out if we can ship the stuff. Did the payment actually get included and confirmed? So that requires a separate process. And finally, we have to somehow represent the address to the user. So the way that I've decided to do this is to, and I think again it's also a very straightforward way to do it, is I present the user with kind of everything. So they get the base 58 address, they get a QR code with a Bitcoin URI, and they get the Bitcoin URI that they can copy and paste in. And so now I'll show you. Now let's go ahead and build the modified T-shirt store. So the way that we do this is we check out the master branch. All right. And then we have to so we've got to add something to the database in order to keep track of information related to Bitcoin payments. Because before we were just keeping track of orders. So what is the thing that we can add to the database? Well, I'm going to add a new table which just keeps track of something called an address path, and I'll talk about that a little bit more in a little bit. The amount in Satoshis, so the minimal unit of Bitcoin that we're charged the user, and also a transaction ID once we observe one. So let's go ahead and update the database. All right, database is updated. And now let's go ahead and, first of all, let's build the client. Oh, we have to npm install again, because there's new dependencies. Like for example, a QR code generator and anything that mentions Bitcoin is all new. So here's where if you don't have those headers for 0MQ message queue, you'll have trouble with this stuff. And also, I've seen a weird error if you don't have if you're on Ubuntu and you don't have Build Essential installed, then you also get an error which doesn't look like that's the reason. So now we've installed the dependencies and can try to build the project.
So what branch are you on here?
This is on master. Okay, so we've got some new stuff. We've got something called wallet, something called client. And let me just make sure. Okay, yeah. So this also builds the server too. Now I change that. Okay, cool. So now we can start the server, and hopefully this works. Oh yeah. So I have instructions that I in the README that I didn't follow just now. So we have to create some file that's some number that's incremented every run. And so if you get this problem that says cannot find session counter file, you just create a file called session.dat and put the number 0 in it. I'm doing this really out of order. So there's a script. If you wanted to do this faster, not in steps, there's an init script. I keep forgetting steps. Actually, I think I have to use the init script now, the way that I've set this up. So actually, let me start over. Okay, cool. So so this sets up the database for you, and it also generates a master key and a wallet 58, which is a public key. So does everyone know what public and private key pairs are? Okay, so we have this is our testnet private key, which we would under ordinary circumstances take much more care with. So like you might do so. Okay, so what is this wallet thing? Well, I just wanted to show you like how you could use a library to implement some wallet related functionality, and then if you wanted to, you could create like you could actually create a secure system, like on a bootable drive or something, and then you have this script there, and some script like the wallet script there to generate keys and to do things like just sign transactions, do the kind of derivations that you want to do, it's the script is designed to be stateless, so you would be responsible for coming to it with something like a request, I want a new wallet, or I want a new public key derived from that wallet, or I want to spend some of the money that's in some accounts that I derived previously, and this will achieve that. So that's what's in this file, and the wallet 58 key. This is a key that we're going to have on our server. We're not going to worry too much about securing this one. This one is a public key. It's actually an extended key, so this contains some extra information that allows it to be part of a larger wallet, but yet nevertheless be the source that you can use to derive additional keys with similar structure. What we're going to use this for is we're going to use this to generate additional keys, one per order. Okay, so now that we've got this, I think it should be possible to start the server. Okay, apparently it's starting. And
Did you run the same database setup command that you did in the previous version?
So for this one, the way that I set this up for this particular, I made a sort of a weird, I made a certain decision about how to do it, and so the command actually does it does the initialization and the migration at once. What you'd really do is like you'd actually be like carefully managing your wallet and carefully managing your database, and you would do the initialization early, like back in time, and the migration later. But for this, if you just run that script npm run init, it'll set up all the files that you need to run this particular version. Okay, so now let's take a look at the updated application. Okay, cool. So this part looks the same, but now there's some additional details. And if you're following along, hopefully you are going to be able to connect to my node. I'll show you how to do that in a little bit. If you just start working with the store, it just won't do anything. Probably will give you connection errors. All right, so let's check out. Now we have a new option here. And so what we get is we get a price in Bitcoin, we get an address that we could send to, we get a QR code that contains the payment URI here, which is just a little bit of a string that represents the entire request. And actually, if you have like Bread Wallet or something, you can load this and just test that it works. But don't, these are testnet addresses, so I haven't tried to like send anything to them, but don't try because I don't know for sure that it will fail.
Goes into the ether.
What's that?
So it goes into the ether.
Yeah. Okay, so then now.
5, 4, 3, live.
Okay, so did you
No, it's syncing the blockchain.
Yeah, no, I wasn't sure if it was really going to be that fast or not.
Yeah.
Okay, so now we can go and we can pay for our T-shirt here. Okay. All right, so.
Is that Bitcoin Core? Yep.
Oh yeah, I'm using Bitcoin QT for this. So this is at Bitcoin/Bitcoin. That's where this is available. And actually, for most systems, you can just get it from your package manager. Okay, so all right, cool. That's this is a very this is the sort of experience that I think a user would probably be happy with. And now we can go over here. We can see there's some message we're watching for a payment. We found a payment we care about. And the last little bit of the program is actually a different script. So we can do npm database equals. So we have something which will go out and it'll look to see if let's say if our transaction is buried under one block or not. And, okay, it's not. Might return to that in a little bit, so we can see it hasn't been picked up yet. but anyway, once this ends up getting confirmed, we can go back and run that script. Okay, cool. So that's the basic flow here. Now we can start to actually look at how some of these features are achieved. So let's see. So let's start with the wallet. So here, the way that I'm using a library called Bitcoin.js, and what this implements is I'm mostly using this for its implementation of various serialization features. So it's one thing to talk about keys and to talk about write expressions like HMAC 512 of some concatenation of things, and it's quite another thing to actually construct those. So this is there's a few implementations of some of the Bitcoin standards out there. This library seemed to be sufficient for my purposes. Unfortunately, I can't give you much of a comparison between the possible libraries. I found this one. It worked for me. Its implementation seemed to be correct. But that's something that if you want to do this in an actual critical situation, you'd have to be a lot more careful in your choice of library. I'm afraid this is not going to be a best practices talk or anything like this. It's just sort of a high concept. Okay, so first things first. Part of the so this is we're working with something called the hierarchical deterministic wallet, which is defined in I think BIP 32, and one of the things is that the serialization of these wallets contains is some magic numbers that say what network the wallet is supposed to be used on. So we have to set that network, and we're using the testnet for this demonstration. So now, the way that this works is we have a subcommand. So we have where we're going to call wallet with a subcommand, and that subcommand is going to tell us what do we do. So we can do a few things. We can create a new wallet. We can create a derived public key, a derived private key, or we can, this is how you might implement a tool which allows you to spend stuff. So we might have accumulated a bunch of transactions in our store, and they're all going to these generated addresses, and we might want to spend them into some wallet for whatever it might suit our purposes better to sweep them every once in a while. In order to derive a wallet, ultimately what this is it's just like in any asymmetric cryptography setup, we just have to know a secret that no one else can guess, right? So I'm just doing this in this way. I'm not a cryptographer or security expert, so I can't say in any real sense how secure this is. But at least in form, this is an appropriate thing. So what we'll do is we'll produce some random secret, and then we'll wrap it up in a bunch of additional metadata to produce a private key. And then that will give us our wallet. Well, actually, it's an extended key. So this wallet contains information related to the private key and also additional information which is used to derive subsequent extended keys. So the first functionality is we just, we can write the wallet out to the standard out. So if you want to test this, actually I think this is a build one. So you can just, it just is a convenience for dumping a key string. And you can, if you're really gonna do this, like you're gonna have specific goals that you're gonna want to achieve. Like you just need to, you'll need to implement something. So like this is how the thing that I wanted to implement looks. And then for the spend feature, so what we'll end up doing is so you if you know a master key, you can refer to.
Can you zoom your browser a little
Oh,
bit?
sure.
Make that larger. Thank you.
All right, was that better? Can everybody see this? Okay, cool. Oh, and I want to encourage, like, if anybody has comments or anything, like, this isn't, feel free to like chime in and
Me and Ian went over this yesterday, and I spent like an hour just asking him questions, and he's very, very nice, and he answers all your questions.
I will. Yeah, I'll try to answer your questions. And of course, everyone's also welcome to answer questions too and ask them and everything. So, I happen to be the one standing, but that doesn't make me different from everyone else. Yeah, so I was thinking one thing that you might want to do is, let's suppose that you've set up a secure environment and it just has this one, it has a master key and it has this one stateless tool in it. Like, one thing that you might want to do is you might want to bring in like a JSON object that represents a sweeping transaction. So you've got your store, and we have a bunch of keys that can ultimately be derived from our wallet key. And so what we do is we just take in some object. Here, I'll show you what it looks like. So we just have we're going to make a transaction whose inputs are described by their derivation pathway, and we'll take a look at what that actually looks like in a minute. And then the metadata that you need in order to construct a transaction. So where was the transaction that generated that output, and what is its index? And then for the outputs, I mean, we just say where we want the money to go. And then when you run it, what you'll get is you'll get a list of, so actually this is an array of these things. So you'll get a list of signed transactions that you could then publish. So you will generate those in a secure environment, take them out to your networked environment, and publish them to the peer-to-peer network. Yeah, do you have a question?
Yeah, I don't know if you went over it, is there like a wallet standard? Like, there's like
Yeah, so this standard is I think it's BIP 32 is the number. Yeah. Yeah, so I didn't.
You're looking at 4 different standards working together.
Okay.
So you've got BIP 32, which is hierarchical deterministic wallets.
Mm-hmm.
You've got BIP 43, which is purpose-based paths. BIP 44, which defines a multi-currency, multi-account set of paths. You've got BIP 39, which is how to derive all of this from a mnemonic phrase C.
Mm-hmm.
So those 4 work together: 32, 39, 43, 44.
Okay. Yeah, and actually, I think, are you guys interested? Because we could zoom in at a later session and focus on just wallets and their structure, and like look at how they're serialized and how some of the design decisions that go into that. Yeah.
I know you're going through this for the sake of giving people background, but I think in general, why does anybody build a wallet of their own these days when there are wallets that exist that you can interact with?
This one has to do with like how do you define like invoice addresses on which customers should pay.
Well, right. You want to the premise being everybody who's going to pay should have their own wallet address that they're paying to, so that you can differentiate who pays. But I don't need to create a wallet to do that, right? I can talk to Electrum and I can say, give me a new wallet address, and I take that and I assign it to this new customer ID to my database, and I know who they are.
But if you have a store, like website store, your website should have a component that can generate addresses, right? From your Xbox.
Well, it should be able to talk to something that can generate it.
Well, but that's what the website is supposed to do.
Sure, but
Well, I think you're asking. Yeah, you.
if you will take that as a part of your code base, or you will, outsource it to something else. I think.
Right. Why build when it already exists?
Well, there are already. I agree. There are components that you can use. If you're using one of the components, right?
Well, I mean, yeah, like this is something where I think there's some danger in doing it this way. I mean, you may be able to satisfy anytime you implement something yourself, at least, especially something which is involves some sort of crypto system. Like, you might be able to satisfy your needs more directly, but you take on the additional risk of doing it wrong, and that's why there's a very strong argument in favor of using a workflow that a lot of other people have used for a long time without incident. I mean, short of mathematical proof, that's the heuristic that
We're
we
better.
use.
There were incidents and they've been fixed.
Well, then you know those incidents were fixed.
But he's early enough in this project, honestly, you don't know where this is gonna go down the path. I mean, the ultimate, I just think that the world is unfair. We have places around the world that control transactions, SWIFT accounts, stuff like that, and ultimately you build a way that someone can build something as a transaction gateway of their own. So I see value in it just personally. I think it's awesome.
I mean, even if you're using a third-party library or system that is trustless, you still need to be able to understand what it's doing and how it works. There are certain pitfalls that are not immediately obvious. Like, for example, in the BIP32 standard, you have to use hardware public key derivation, otherwise, under certain circumstances, you end up with a key compromise. You don't know that unless you've read the standard and understood how it works. So even if you're using somebody else's tool, you know, you're going to have to type in a BIP32 path at some point. How do you pick that path, right?
Yeah, and I would love to know the answer to that question, actually.
I mean, the bottom line is that there's a difference between learning how these things work and writing all the code yourself. You don't want to do that in a production environment, but you still need to know how these things work. Otherwise, you can't really use somebody else's library properly.
Yeah, that's a good point. And this is very much something that I made to learn something, and I didn't learn everything by doing it. And again, I think it's I think it's probably obvious to everybody that there's a whole giant network of additional concerns. So I hope that I'm not actually doing a disservice by showing this. I wanted to play with the stuff and, you know, see what I could do and maybe make a few decisions. But yeah, that's it. There's a lot more to learn, and I think it's sort of useful too. I mean, it's maybe, I don't know, and optimally, if somebody finds it's sort of like what you were saying, if I have this on the screen and somebody can point at something and say what's wrong with it, and I get to understand that, then that helps me out. Hopefully it's not something that, I hope to not give people wrong ideas though, and I think, you know, Bitcoin is, and any of these trustless peer-to-peer systems, I think that's, the subtle problems are, I don't know, it's like, are they best left to the experts? Is that kind of the state of affairs? I don't know.
No, you need to understand the implementation. What Andreas was saying, like, you first need to understand BIP32, then you need to see, you know, implementation of that, and then you need to evaluate if it's not already evaluated by the people you can trust.
But that depends on what level of, what you're working on.
Sure.
I mean, because as a web developer, you don't need to know how all the different protocols work. It can be a black box, and you know, you put these inputs in, you get this back. If it's gotten 6 confirmations, I'm probably good, and you take it from there.
Sure, I mean, that's, you know, your opinion, man. I'm saying, I'm actually working.
I have been doing this for a few years.
Well, I mean, it's
no, but I'm actually
It's different goals, right?
Yeah, exactly.
You're
That's
trying
what
to
I'm
learn the
saying.
store, and he's trying to learn how
Right.
BIP32 works.
Right.
And those are not
It
necessarily
depends
the
on what your
same
goal is, absolutely.
goals, right?
I'm actually making like open source store. It's BTC Pay. You can look it up on GitHub. So I agree with you. Like my interest is kind of different.
Well, you should
We
be
were just
creating a tool
Yeah.
that someone can use as a black box.
Yeah.
Well, there
But
we
I
go.
agree. We can talk more about it if people are.
Yeah, but
Yeah,
what we're doing here is we're not building production stores, we are tinkering to learn. So
yeah, we're tinkering. Yeah, and And I think we're also trying to figure out, you know, what you guys want out of the developer series, too. I mean, I think it's I would love for people to just, you know, if we could get members of the community to walk through projects. Maybe some people are more professional, some people are less professional. Sometimes we just, you know, try to do something and see what happens.
Let's do atomic swaps, man. A series on atomic swaps.
Yeah.
How do you do that?
Yeah.
I think this just adds to decentralization, right? Or else we're all going to be using Coinbase and BitPay.
That's true.
And you know what? BitPay doesn't even give me a public address I can pay for my hardware wallet.
How to put 72.
So, I mean, this is cool.
Okay, but yeah, as long as we learn something and it's fun. Okay, so so now we define our place. So we talked a little bit about, you know, there's a little bit about some of the things you might start thinking about when you set out to run your own wallet. So like one of the things that we learned is, you know, there's some tiny abstract kernel, which is like you have to somehow manage some secrets, and then there's an entire giant structure of knowledge that's required to do that well. Okay, so now I think I'm probably going to focus on stuff like how do you integrate with other existing tools or other existing software. So the things really the only other piece of software that we need to integrate with is the Bitcoin node here, and we're also going to make one API call. So, all right. So the way that okay. So let's look at this. Let's look at this how the server and some of the features that are now added to the server. So before. All we were doing is we just set up a WebSocket connection and we pushed some data to the user, and then we waited for them to send us an order, and then we just sent a confirmation back. So now we're going to push some data to the user, and we're going to wait until we hear back from the user, and we will first we'll record the order in the database. And then we have to do different things depending on what kind of order it is. So if it's a credit card order, we just kind of like bounce back to them. It's fine. If it's a Bitcoin order, well, first of all, we need to actually tell them what we have to quote them some Bitcoin price, right? They have a dollar price, and so the way that I did this was I actually went out just to Coinbase and asked them what just give me a spot price. So just hitting this API. That's one way to do it. This is a little bit, I think I was working a little bit late, but anyway, I wanted to produce some sort of, so I'm generating, I need to produce some unique path, so I was thinking, why don't I create some path that consists of the sequence of which run this is in the sequence of all runs that we've done, together with which request this is in the sequence of all requests that we've encountered this run. I don't know if this is a good way to go.
Is this for the BIP32 path?
Yeah.
This is not a good way to go.
It's too predictable, right?
That's not the problem. The problem is that BIP32 has a defined generation derivation scheme.
Yeah.
And wallet, if you try to import that same seed into another wallet, that wallet's going to look on a very specific path for these first 20 addresses and check whether they have UTXO. And if you've gone outside of that path, it won't find your stuff is somewhere, but it's impossible to search.
Well, sure, but this is maybe two things that I've done that are strange cancel out because I built a wallet that I'm keeping the paths in the derivation paths as a
If you lose that database, all your funds are gone.
Yes, that's true.
So that's a single point of failure. So you have no backup on the BIP32 key.
Okay.
And this is one of the problems you have. People don't appreciate what BIP32 is. We're talking about a tree that has a 32-bit index. That's 4 billion children per parent, which have 4 billion grandchildren each, which have 4 billion grandchildren each to infinite depth. If your path was somewhere in there, you would have to do 4 billion times 4 billion times 4 billion lookups on the actual Bitcoin blockchain to search for specific UTXO after you've done elliptic curve multiplication, 2 double SHAs, and a lookup on the blockchain. We had to do recoveries on keys like that. You're talking about running a GPU farm for a week just to search the tree. And you may not find everything. So it's better to simply follow the BIP32 standard and BIP39 standard where you start with the first address in the account, the first receive address, and you keep track of how many addresses outstanding you have. That's another problem with the store, which is if a customer abandons their cart or doesn't make payments within the 15 minutes that you've allocated, right? You have to then reuse that address for another customer later. So you don't leave a massive gap of unused addresses because then it won't be liquidated. And so you have to do all of this address management, which is quite complicated, and a lot of the tools do it for you. So BTC Pay, Mycelium here, Coinbase Merchant will do all of that for you. It's tricky. You can basically get your payment, stick it somewhere in the path, and not know where it is.
Okay. And so so in that case, are the paths predictable then? Is that how that's handled?
The paths are predictable.
Yeah.
But only if you have the master public key.
If you're the yeah, sure.
If you don't have the master public key, all of the addresses are uncorrelatable. You can't tell that this is what the next one will be or what other addresses are being given out. So there's no privacy issue there. If you're a customer and you see one address, it doesn't tell you anything about what else the store's doing.
Okay, so in this case, no, this is awesome. I mean,
this is how you learn.
Yeah.
This is one of the examples of why you have to be careful when you're rolling your own scheme.
Yeah.
I'm not curious if you have anywhere like where there is a list of all the paths, because I was trying to add Dogecoin to BTC Pay, and then like you couldn't find the standard path, so people would just use the 401, which is like standard path.
There's a standard by Satoshi Labs, which is called SLIP44. SLIP 44, and it has a list of more than 300 currencies and the correct currency code for each. But not all currencies follow that. And then some of them have change addresses and some don't, so they might not use the sub account. We had to write, in the company that I participate in that does a lot of recoveries like that, we had to write custom software that goes searching through millions of paths to find lost money.
I was hoping that there's no standard.
Slip 44.
So I think I missed the question earlier. Did you have a question?
No, I was just saying great job.
Oh, thanks.
That's impressive. I was just curious if there was
I mean, actually, the way that I tried to do this was I tried to kind of so I knew I was going to get some stuff wrong. So what I tried to do is I tried to think about it from first principles. So that's like a class of errors to make. But I think it's like I can explain the thinking. There's not a lot of preliminaries. So like, yeah, I'm going to get a bunch of stuff wrong. But like, I think everyone can follow like how the decisions were made. Yeah, so that's awesome. Okay, cool. So, right. So, here? Ah, yes. So in this case, yeah, and I'm not even deriving a hardened key for this for either part of the path. But anyway, so now I think I'm going to treat considerations on the wallet and the key derivations as open, and now they're asynchronous. So the next thing is once we so we have to do two things. So we have to, now that we have an address and an amount for the user, we have to watch for that amount to hit the mempool. And so I implemented an integration with the push service that you can get from Bitcoin. So this uses this library ZMQ, which is just an abstraction over a TCP socket in this case. And what I'm doing is there are 4 different feeds that you can subscribe to, and I'm subscribing to the raw transaction feed, and I'm using this library, the same library bitcoin.js-lib to parse the transactions, and I'm just looking at each transaction, and I'm getting the address here. So this service, what it's doing is it's creating an event for every transaction output that it sees, with it prepared in a way that the rest of the software can understand. And going back to...
Is that looking just for your addresses, or is it looking at everything?
So that's looking at every transaction every new transaction that arrives at the node. Yeah. So I don't know if there's a way to get the node to filter it, but somebody has to filter this. And so I've taken on the thankless work of filtering the transactions. So now we're using the heuristic that the first transaction we see with the correct address that has at least the amount that we expect, we're going to consider that to be a user. The user has at least attempted to pay. And then we update the database to record the derivation path and the transaction where we saw that payment. And we set the status to confirming, so we know that we've seen the transaction, but it's not confirmed yet. And then once that's done, once that's registered, then so we send the user a message saying that they can go ahead and move on. So that's pretty much it for that part of the store. It still remains to be seen, how do you actually check for whether or not the transaction is confirmed. And for that, I wrote this checker script. And what this does is this gets all of the transactions from the database that are where we're not sure if they are confirmed, and then it opens an RPC connection to our Bitcoin node, and so one of the things that the Bitcoin node will tell you, among other things, is if you give it a transaction ID. Oh, and I forgot to mention, there's also some configuration that you need to do on the node, and I'll go into that in a second. So one of the things that you can do is you can essentially ask the node to just tell you, given a transaction by ID, what is the how many confirmations does it have? So how many blocks are above the block that it sits in, inclusive. And if there's so then we look on the command line for the number of transactions with the default of 10, or sorry, number of confirmations with the default of 10, and if we actually do see a confirmed transaction at that depth, then we can set the status to paid and move on
Was there some logic behind using 10 there for your number of confirmations?
So
I see 6 used a lot.
Yeah. I mean, I don't know. I think it's something like, you know, how many joules would it take to reorganize, to reorganize that section of the blockchain? So, I mean, I don't know. There's probably somebody somewhere who's done some calculations saying, here's a bunch of So,
page 8 of the white paper.
That's where the 6 comes from.
White paper
Oh, that's where it says
That's where the 6 comes from.
That's where it comes from. It calculates the probability of a reorganization after 6 confirmations. It's about the only piece of math that's in the white paper. There's a couple of risks in the way you've done it here, and I think it's a useful learning experience for this particular issue. One of them is transaction variability.
Mhm.
So if you're looking at transactions that are not to segment addresses, which are not between segment
yes,
addresses
not
here, the person who has sent you a payment can have their transaction validated by a third party so that it gets confirmed but under a different transaction ID. Because you're looking by transaction ID, this is exactly the bug that took empty GOPS down. This is what drained your wallet and caused it to go down the first time. They were checking whether withdrawals had happened by sending a transaction ID to Bitcoin D and getting a false response. They were getting no, but the withdrawal had actually happened under different transaction IDs, so then they double withdrew and triple withdrew and withdrew all of it. So there is a way to get around this, which is a slightly better way of getting this information from Bitcoin D. You can add addresses to Bitcoin D as watch-only addresses, and then you can check the balance of those addresses. And that takes into consideration transaction variability and other little tricks that might cause problems. And you can set a threshold of how many confirmations you want for that query. So that's probably a slightly better way of doing it. Because if you're just looking, and the same thing with the WebSocket, if you're looking for specific outlets, there are some ways your software can be fooled into thinking a payment has been received when it hasn't, or vice versa. False positive or false negative.
So I actually tried to do that, and it was very slow to scan for. Is there a way to configure it to only scan back, you know, like 200 blocks or something? Like you just process and you look for you want to see and whether an address was mentioned in some recent blocks.
You index everything, so you do a full TX index. So if you do that, then it's fast because it keeps a full transaction index in the database.
Yeah, you do have components that you can put on top of Bitcoin node that do exactly what you're doing.
Yeah.
What he's saying, like what we use in BTC Pay is Entity Explorer. But that's what Nick wants to do with that exactly because you get problems with like monitoring exactly what all that is. So you're on the same path.
Yeah, this is a problem that goes back 5 to 6 years, where there's been a request essentially to offer this functionality directly on Bitcoin D, and they have deliberately said no because they don't want to have that in the consensus. So all of that's done as secondary layers, which is why BitPay has Insight Server, which does exactly that kind of indexing, and NB Explorer or that, Bitcoin and Bitcoin do that as well. It's you've run into a classic thorny problem that is something
I'm gonna edit
everybody
this.
who tries to make
I'm gonna mention the Mt. Gox problem in the here. So don't make Mt. Gox problem. Fix me, Mt. Gox.
Just one last question on the 6 topic. Is that something that depends on real world parameters that might affect like how long forks persist for? Or is it somehow like it will be 6 forevermore regardless of how the network evolves? Does anybody know?
I don't know. Does anybody know?
6 is an arbitrary number. It's like there is no magic number in which a confirmation is final. 6 is just where the probability drops below 4/9 of probability of a fork.
Regardless of network size or number of miners or block size?
If 100% of the miners have been taken over by an evil genius, then the number of confirmations you need is infinite, and it's still not enough. It's not regardless, no. It assumes you have an honest set of miners who are greater than 51%. And under those assumptions, the probability of a reorg beyond 6 confirmations is less than 0.0001%. And that's the equation on page 8 of the white paper. But it's a matter of risk tolerance. You know, it's cup of coffee for 0 confirmations, flat screen TV for 1 or 2 confirmations, car for 3 or 4 confirmations, house for 5 or 6, aircraft carrier for 10, etc.
All right, excellent. Let's see. So.
I sold the car for 3. I'm not kidding. That's not a random example. I sold my car for 3 confirmations.
Is that like did you deliberate for a while?
You mean you let him drive? You mean you let him drive away once you had 3?
Yes.
And what kind of car was it?
Mini Cooper.
How fast was the car?
I think the only other thing I really wanted to touch on was a little bit of configuration for the node. So this is you have to set a few key value pairs in order to get it to behave the way that you want. So if you're going to play around, testnet equals 1, first thing that you put in your config file. And then you can do things like you can customize the amount of memory to use that the database uses, its workspace. You can put a message so that anybody who cares what the user comments are can see that you are running this demo. You can route your connections through the Tor network.
Can I just point out those two are contradictory? Like if you route it through Tor and then you put a message that says this is Bob Chicago.
Very good. Yeah, so your motivation for using both of these may be unclear, but you can do it.
Showing off.
If you wanted to, maybe you want to place additional load on the Tor network or something. Yeah, so we need to index transactions so that we can actually do those lookups, even by transaction ID, I believe. And we need to be able to ask the node questions. So we want the node to be able to tell us things, and we want the node to be able to ask the node questions. So here's just a very simple configuration file, and how much you want to expose your node to the outside world depends on a lot of things. I'm running essentially using it to understand the database of Bitcoin output balances. That's it. So I don't really need it to be super secure as long as it. My threat model here is I don't want somebody to change it so it lies to me about stuff, and I don't know how to mitigate that by configuring this differently. Okay, cool. So that's about it for the walkthrough. I'd be happy to go over anything to revisit anything or help anybody get their build working. But at this point, I mean, I think it makes sense to either continue the discussion or go for a beer. And thanks for showing up. This is I had fun. I hope you guys all had fun. Yeah.
As random as this may sound, but it's like one of those moments when you're in a room with like Yoda and you want to ask these questions. So between the two of you, what would you all recommend for having this kind of like short mid-term to make this into an awesome project or a project that he's already invested so much time into? I mean, clearly everyone else, but I'm like, when you all, because you came out for a reason, and I'm like, you brought up a great guy.
I think it's a great demonstration. It's like I think he did it in a way that like us as developers here, like we get exposure to certain. It's like how do you code something. As for how like I would turn this product, I
So
Florida
we're-
tea.
Yeah, it's Florida.
Different.
Yeah.
No, I think that was great. I mean, one of the difficulties in this space is that people tend to be very specialized. So you have people who are focused only on back end or only on photography. And taking that broad perspective where you go from a client to a front end, node application, a website, all the way to Bitcoin D and interacting over RPC and WebSockets, that's the kind of broad technology you need to be a full stack developer and to understand all of this. So I think that's a great way to learn about it. An actual application that you can see end to end. Otherwise, all of these things hanging by themselves, you don't run into the kind of challenges that will force you to understand the protocols. You have to have a goal, and selling a T-shirt gives you that goal. Yeah, I love it.
Yeah, I think there's I can see another branch here too, which is the hardened branch, where you get to see, here's where we start, and we can actually showcase, if you guys want, I mean, feel free to submit suggestions for hardening this thing, because that could be useful too. I mean, yeah.
You might have mentioned, I missed it, but, so you run on testnet, but it looked like the ports you were running on were non-standard ones?
Oh, the ports I just chose arbitrary ports.
Okay.
Of the NPM packages you used for this, which were the ones that you liked and will probably go back to?
Well, that's the thing, is that I only used, I kind of, to put this together, I'm unfortunately a person who procrastinates, so I didn't give myself a whole lot of time to experiment, and so I think what I would do is I would actually try I would try to find alternatives and investigate them for that would be like the next step, and then I would have to choose.
But are there like a couple come to mind that seemed nice, or?
Yeah, I mean, they I would have to have a lot more experience with them to really say whether or not I prefer one or the other. One of the problems is always, for me at least, is understanding like when this is fine. It wasn't super important that they were correct. Besides, I don't want anybody to come away thinking there's some kind of guarantee about these things. But that would be one thing, is just to understand everything well enough to get some clear sense of whether or not all the dependencies are correctly implemented. And other than that, it's like as you saw, I like to write TypeScript, so I prefer things that are designed with that in mind. It's slightly different. It's a slightly different style than just pure JavaScript.
And what I thought was interesting about watching you go through all of this is I do e-commerce websites and everything's made for credit cards, And so it's a very different process. Like the core code of that e-commerce platform is set up to, ping a server, with some credit card information, collect it, send it off, get a response, you're done. And so it's a very different scenario when you're like waiting for these confirmations and you have to track these transactions. And so that was interesting to watch you walk through that. So that was cool.
Yeah, most of the e-commerce plugins are kind of broken when you try to use them for this stuff. Blockchain just released a Lightning Charge, which is a server for doing Lightning payments on WooCommerce with a WooCommerce plugin.
I've
I
been
had to go
talking
in
to the
and
guy.
hack
Yeah.
WooCommerce
Yeah.
because it insisted on collecting a billing address
Yes.
The worst.
and a
Yes.
shipping address from every customer.
Yes.
It's like, I'm selling a virtual product for virtual money. There is no address. Like that's the whole point, is not having an address.
I forked
But
that guy.
WooCommerce
Yeah.
has it mandatory. You can't check that off because no other payment system can be done without an address.
And I took his work and I'm trying to do the same thing for Drupal Commerce, like make a Lightning payment plugin, and I can't get around the effing credit cards. Everything's set up for that flow, that process, and yeah, it's a big pain in the butt. Yeah.
All right, calling it.
All right.
Thanks, Ian.
Thanks so much, guys. Yeah, and very happy to have suggestions, requests for, we're trying to make something out of the series. So, if anybody has anything that they want to see, or if you want to, maybe if you're thinking about, if you might want to give a presentation, or if a friend that might give a presentation, that's fine too. I mean, just let us know.
Let us know. All right, Ian, say goodbye to YouTube.
Bye, public.
Yeah, that's it.
Could you display a link